Hi, thank you for clicking on this video, and today what I'm going to share is how to create a calculator logic for your calculator. So resets it, and if I were to times it, it will become 56, and if I were to do a new equation, it becomes 10, and if I were to do continuous, 5 plus 6 plus 4 minus 2, then it will have its result over here. So this will be a very long tutorial because there's a lot of use cases that I'm going to go through. So buckle up, let's move on to the video. So this video is a continuation of my previous video about neuromorphic calculator. So check it out before you go to this tutorial. Okay, so the first thing that we want to do is to make this number change accordingly. So I have this calculator. If I were to press 9, it will say 9. So our initial number will be 0. And then if we were to type in 98765 or something like that, it will show accordingly. So that's the first step in order for us to create our calculator logic. Now inside our new calculator button, let's create a parameter that's called onPressed. So we use this void callback. It is just a type definition where it just returns us a function. So a signature of callbacks have no arguments and return no data. We are going to put this onPressed inside our onPointerDown function. This is where our thumb press on the button like this. Alright, widget.onPressed, and then you'll put the brackets. Okay, now the next thing is that this widget onPressed is a function itself. However, we are unable to make it into a null over here. So an example of what Flutter team or community do is that if they were to create a flat button that requires an onPress, if I were to look at it, it is required. So that's the only way that you can have the onPress as null. So let's have this required syntax or word over here. And now our calculator buttons will shout an error that says parameter onPressed is required. So let's do that for all the buttons. So I have with me all the calculator buttons with an empty function on onPressed. So this signifies an empty function. If I were to click any of this, it doesn't really shout an error. If you were to look on debug console, nothing really shouts anything over here. Okay, the next thing is we are going to use a state management in order for us to have our numbers being changed. So I wanted to do a MOBX tutorial on like the introduction, but once I have looked through a tutorial and video about MOBX, MOBX is actually very helpful if I were to have some async functions that I want to do. Like for example, you want to work with Firestore. So they make use of observables, which I think the calculator does not need, and reactions. So reactions are like side effects, or basically like when a user signs in, then you have reactions. So you are listening to, for example, Firestore to see whether the user is logged in, and then you will have reactions where all of your UI will change accordingly. It's very useful for network calls or anything to do with network, but in this calculator case, it doesn't need to have a network. It can actually work offline. So that's why MOBX wasn't part of this tutorial. Maybe next time. So in the end, I chose a very simple and inbuilt kind of state management, which is change notifier. So if you were to go to main.dart file, you could see that our calculator uses a proxy provider for its theme. And we are going to use change notifier provider. So if you have two providers that you want to pass into your app, you can use this thing called multi-provider. So type in multi-provider, and then it requires your providers, which is a list of provider, and you can copy this whole thing and paste it over here, and you can just move your child into the child of the multi-provider. So let's make it nicer. Okay, next thing is we are going to create the change notifier. We're not going to create it over here. We're going to create it in a new file. And under this new file, let's call this calculator underscore logic dot dot. This is where all of our magic of the calculator will live in. So I was thinking whether should I put in calculator logic or calculator. So I realized that I think with the logic that I have created so far, it can be worthy of a package itself. So that's why I'm going to name my change notifier as calculator instead, because it has the function of a normal calculator that you can use. So let's extend this into a change notifier, and let's import this from material.dot file. Okay, the next thing is that we are going to have a property that will change accordingly. So I'm going to use this num variable, which is called value, and let's make it private, and let's set it to 0. Then we will have a getter method, so a num get method that's called value that returns the private value variable that we have set. So this getter is good because it doesn't allow us to change the private variable that we have. It just exposes what is allowed to be shown. Okay, the next thing is we are going to put our change notifier in our main.dot file. So let's remove the observer, and let's put in change notifier provider, and let's put in the type calculator, and this will import from our calculator logic.dot file, and this has the create method, which is the calculator instance object. So at the same time, it has only one argument, so let's ignore this and let's return this as calculator itself. And I think we don't need a trailing comma. Alright, now if you were to go back to calculator view, let's grab the calculator variable from the provider. So let's create a calculator variable, and let's put in provider.of context, and then we can at the same time put the type calculator, and we can import both libraries and providers. And with this calculator, we can put inside our text widget, which says 3670, and let's put in value .toString. Alright, so let's save this. Okay, so let's save everywhere. Okay, now it is started at 0. So we start with 0, and now if we were to press 7 and 8, it will show 7 and 8. If we were to go back to calculator.logic.dot, let's create a function that's called set value. It might be a setter method, but it's not really. And then it will take in a number, which is called number. Then as simple as value is equal to number would kind of work. So if we were to go back to our calculator view.dot, and if we were to just make use of the number 7 and 8, so let's put it calculator dot set value, and let's put 7, and let's have this shortcut. Alright, so if we were to put 7, nothing happens because we are missing one function that is called notify listeners. So this will help us update the UI, and now it says 7. So if you were to type in another 7, it just remains at 7 because we are only setting the value to 7. So we need this 7. So if I were to press another 7, it will represent 77. So how are we going to do that? So what we are going to do is we are going to make use of strings. We are going to stringify our value, and then we are also going to make use of this concatenation, a very simple plus that will concatenate two strings into one whole string. And then this will help us make our number here act as a calculator. So our initial number will be 0, and that means our value will be the number itself. It will become 7. However, once you want to add another number behind it, you need to concatenate or add the second number behind, for example, this 7. So if you were to put 8, then it will become 78. Then at the same time, you want to parse it into an integer so that our text widget in our calculator view will be listening and will update accordingly. So let's set our number 8 to be responsive also. So for me, I don't like to have all of the numbers to be responsive, because if I'm able to have the set values to be on 2 numbers, then I think it's enough for testing. So let's change this 7 to 8. And now if you want to press 7, it becomes 7. If you want to press 8, it becomes 8, 7, 8, 7, 8. So that is the first thing that we have done so far. Now, this AC actually will reset this whole thing. So how are we going to do that? We're going to create a very simple function called reset. So you can have the function shortcut reset, and then doesn't need an argument, so let's have space. It is a void, and then this underscore value will become a 0, and this will also change the UI. So let's notify the listeners, and at the same time under calculator value, it is at the top. So let's have this shorthand, put calculator dot reset. So the thing is that if it doesn't have any value needed, we can just remove all of this syntax, because this on press will then be inserted inside our calculator button, which then converts this void callback into a function itself. So that's one cool thing about Flutter. So if we were to put reset, it becomes 0, 8, 7, 8, 7, reset. Excellent. Now the next thing is we're going to have a simple use case. So if the user press 7 plus 8 and they press equal, it becomes 15. So I want to draw it out so it's easier to see what it looks like. So if I were to put the user action and result, we'll see how it goes again. Okay, so the user action, when user press 7, the result will show 7. So the second thing is that the user will press plus and the result will still be a 7. Now the third action is 8 and the result is 8. And lastly, if I were to press the equal, it becomes 15. So with this, we should know that the plus will just remain as the 7, and we have the equal that shows the result of 15. So having all of these steps being visualized is easier, because once we're going to have other difficult use cases, this will be very helpful. So the thing is, all of this user action, it actually looks like a very simple, I could say, pattern. So there is the number, and then the next thing is operator or an action, and then the next thing is the number, and lastly it goes to like an action. So you could see that to have a proper equation in a calculator flow, there will always be a number, action, number, and action. Okay, so you could see that the user action will actually become like a list of actions. Alright, so we want this to be a list of actions, so we can have like a list of strings. However, to differentiate between each other, we probably need to create object. And we are also going to use this package, which is called math expressions. And this allows us to parse and evaluate mathematical expressions, or you could say equations. And from the example itself, you could see that they just parse the math equation in a string, just one string. However, you don't see the you don't see the equal sign. So this equal sign will be, you could say, invalid or something that we will make it into a function to calculate this whole list of objects. So we are going to do this. We are going to create different math operator objects, plus, minus, or divide, or even times. And these 7 and 8 will be another object that will have numbering itself. So first we are going to create like an interface. So an abstract class that we are not going to use or instantiate. So that's what abstract means. This is not meant to be instantiated. And at the same time, we have a field that is called value, because we want it to return us a string that we can combine them into a string that we can parse using the math expression library. For example, parse, and this will return us the value 15. We require a string from each individual object that we create or instantiated. So that's why I have created a parameter. So we create this string value because we don't need to override, because we are still extending it. So an example is that if we were to create an instance of this object, by having dot value, it returns us this plus. That's why I've created this thing. So same goes to the other objects or classes that I've created. So like add, multiply, divide, and deduct. So you can see that the divide is not the same, because in programming, this is how you divide stuff, not using this. And to times or multiply, you use this star instead. And lastly, I have this calculator number with a compulsory parameters, because the calculator number always has a number inside. However, it is a string, so you have to be careful with that. Let's create the initial list of calculator variables. So I call them actions, because the different calculator has its own action, like add, multiply, except for the number. Maybe I need to rename this something that makes sense, maybe calculator typed number. And it will actually get this calculator number 0, because we started out as 0. Alright. So what's the difference is that this value 0, you could say this is the result that we are showing, and this actions is just what we are putting, the different actions that we put inside the list for us to calculate in the end. So we put this as 0. So now we're going to create the add. The first thing that we need to do is, so once we have a number, for example, it starts at 0, we are going to add a math operator action, which is a plus. So let's add it inside our action. So underscore actions dot add, and then we can type in calculator add, and it's an instance. So let's save this. So the next thing is that if we were to set the value or change the number, we also want to change the number over here. We also want to change our calculator number, which is the initial 0, to what we have typed over here. So how are we going to do that? So what we can do is that we can remove this object in this index and then create a new one. Like for example, if you were to type 8, it will create a new one, 8. So the first code of line actions.remove last will just remove my first number that I've initiated, and then after that I will add a calculator number variable and using the value that has been typed. Okay, so let's see how our logic is working right now. So if you were to press 7 and if you were to type in actions.first.value, it returns us 7. So if you were to press 8, our first action will become 78. So let's see how it looks like. Let's try again because I missed out. So if I put 7 again, so actions is still calculate the number, and then if we will type first value 787, great. So our value and our first action calculator number is 787, which is yes, correct. So I forgot to put in this add method inside our calculator view or our calculator button. So our plus does nothing at all, so it's okay. So typing calculator.add. Okay, that's it. Save this. Let's have this and this breakpoint. So we type in 7. First value is 0. Never mind, let's undo this. So let's see this. 7. And it will notify listeners as 7. Okay, the next thing is that we want to put this before the remove last. Press the plus, and then let's press 7. So inside our actions, you could see that we have calculator number, we have calculator add, and now we're going to remove the last one, which is the calculator add. Let's see how it looks like. Now suddenly we have calculator number and calculator number. But we want to have the plus button, but we removed it. So how are we going to prevent this? So if we were to see our end product is 77, which is not what we want. It is 7 plus 7. So we are going to have to create a conditional to see whether our last action is a number. So this remove last will only happen when is actions.last is calculator number. So let's save this. And now let's see how it looks like. And let's restart this whole app. If I were to press 7, just continue, press plus, and press 7 again. Okay, so now our actions have calculator number and calculator add. Do you think action.remove last will happen? We can do a breakpoint after this if statement, and let's see how it looks like. If you hover over actions.last, our calculator add still remains. Then if we were to just have this, it has number, add, and number. So that's great. That's what we wanted because we have 7 plus 8. And let's continue. So it works. However, our number over here doesn't look like it's actually working. We don't need a 77. We need just a 7 itself. So how are we going to solve this? So in order for us to reset this number, the only way we can do is that if value is equal to 0. So for example, 7 plus, and this will actually set the value to 0. And if you were to press another number, it will turn into that number itself. So what we can do is we can have this thing called actions.last is not equal to calculator number. So if it's not equal to calculator number, the value will then become 0. So at the same time, we can definitely have some refactoring. Let's make this into a variable, extract local variable. So you can say last is or last action. So over here, action. And let's put it over here. Okay, and this should be a final. I don't like using variable. Oops, final. Okay, so after refactoring, it looks something like this. Final last action will be our last action that we had. So what we did just now was, so first we type in the number 8, and then we press the add. The value still remains at 8. Then after that, we want to press the number 9, for example, number 9, but it will show 89, which isn't what we want. So how do we resolve this is to check our last action. For example, it is a math operator. If this is not a number, then we will set the value to 0. And then when someone press another number 9, then this value will become 9. So how we put that into code is to have our last action to see whether our last action is not a calculator number. So the cool thing is that you can use this is not, and then we can reset the value as 0. Okay, so let's do that. Let's remove our breakpoints and refresh this. So since we have 7 and 8 working, 7 plus 8. Alright, so it's working. And if we were to put 8888, it's currently working. And lastly, our last action, the equal sign, will pass our list of actions into a string, 8 plus 9 for example, and will set our value to be the result, which is 17. We're going to create a function to do that. So let's create this function called parse calculator actions, where it takes a list of actions and it will return us result of the actions. The first thing is that we want to put this list of objects into a list of strings. For example, 8, and then we have a plus, and then we have a 9. Okay, so how are we going to do that? So we're going to create a variable called math variable, which is a list of strings. The next thing is to have to go through each actions and add the action dot value. So the next thing is to make this list of stringified actions to join together to become 8 plus 9. So we are going to use the method, you're correct, join. And we're going to put the result of the joined strings inside the list to be called equation. Then after that, we are going to use the math expression library for us to calculate our mathematical equation. So inside your pubspec YAML file, let's insert the math expressions dependency in. So let's save this. You can technically print the equation and let's see what it looks like. And put this parse calculator actions, put it inside a function called results, put it inside with underscore actions. So let's save this. So at the same time, we put this result function, keep on forgetting, into our equals button. So on press, let's put in calculator dot result. No, this should be show result. Okay, let's change our So let's save this. Now let's open up our debug console. Let's clear it. So 7 plus 87. Alright, so now it looks exactly what we have typed here so far. And we are now going to calculate the result and see how it looks like. So using the math expression parse object, you are able to parse this string, we call it equation, and then we will evaluate it using this enum. So evaluation type real. And then at the same time, we are going to use this context model because the evaluate uses type and context. This parse usually is used for difficult mathematical expression, but for us, we are just doing a very simple, real kind of equation. So once it's evaluated, this will then be in our result variable. So let's see how it looks like. Let's save this and refresh this. So if you were to put 7 plus 78, and there you have it. Our calculator has finally finished 7 plus 78. However, it is returning us 85.0, which is not exactly what will happen if I were to type in the same exact equation, for example, like this. It will just only show 85, not 85.0. So how are we going to determine whether this has a decimal place? So we're going to make use of this function called isInteger. So basically what it does is whether first the value is an integer, this is obviously a num or a double. Then after that, it will round to double to see whether once it's rounded up, it looks like an integer because it might have more than one decimal place. By using the function isInteger, I'm able to round up or just return it if it's a double or a num. Then with this prettier result, I will return it, and this parse calculator actions returns us the result. So we can have the value equals to the parsed calculator actions. And at the same time, we want to notify our listeners. So let's save this and we will see how it looks like. 85, great. So if you were to press AC, it will reset to 0. However, if you were to press 8 plus 6, 7, there's 7 plus 8 plus 7, which is 22. And we press AC, so plus 7, 29. So actually, we are getting the previous result and adding it in. So when we press reset, plus 3, 6, 8 again, it is not resetting our variable actions. So what we can do is, in our reset, we should have our actions to be this initial state. So if we save this, and if you press AC, and if you were to put 7 plus 8, so it resets our previous example over here and put it as 7 plus 8. So if we were to just reset again and we say 88 plus 77 equals 165. Correct, so it works. Okay, so the next thing is that what if we were to have, let's cancel this. We have 7 plus 8 plus equals. And there's actually an error. So invalid value range is empty minus 1. So inside our parser, we are not able to get this equation. This equation cannot be parsed. So how can we prevent that if we were to press the equal sign? So what we can do is that if there was a plus and then we press the equal button, then the parse will just remove this. So how are we going to remove this intelligently? Well, if you see from the pattern, most of the time the add method or the math operator is on an even index. So when the user pressed on this equal button, when we calculate this whole thing, we will have to remove this before it gets stringified. So we will not have this at all. And then once we remove this whole thing, then it will just be a normal equation that we can equate to, which shows the value of 17. Okay, so where should we put our conditional statement to check whether our actions is even? So we can put it after this because we don't want to change our actions. We just need to put it over here. So once the math variable has all of the actions, then we can check whether the length is even, and then after that we can just remove the last element or the last action. So we save this, and then let's reset everything, and let's open the debug console to see what it looks like. So 7 plus 8 plus 87 plus, and let's equal, and you could see that it's working now. Great, so we have solved one bug. One bugger. So the next use case is that if you were to have 7 plus 8 and we press the plus again, it will return us the value 15. So if we were to go back to our user action and result, instead of the equal, let's remove this, we press the plus or add, it will show us the result 15. So how are we going to do that? Well, inside our add, we will just show our value as 15 then. So in our add over here, there's actually another bug. Let's have a breakpoint over here and let's refresh everything. So if you were to press the plus, there's number and add. Great. If we were to press the plus again, there's add and add. So over here with two adds, we can prevent this by just having a very simple if statement to prevent another calculator add. So if actions.last is not calculator add, then we were able to add a calculator add. So let's run this, and if we will reset this, okay, so 1 plus, so the actions now has add, okay, and then we have add again, and it will just remain to have one add, which is good. Alright, so we have resolved that bug. Now the next thing is to show the result if we were to have this user action over here. So what we can do is that we can just set the value as the parsed calculator actions, and we will notify the listeners. Okay, so let's do that, and let's have a simple 7 plus 8, and if we were to press the plus, it will become 15. So this works. If you were to press again plus, nothing happens. Press 7 plus becomes 22, 8 becomes 30. That's great. What if you were to press 7 plus 8 plus minus? So we change and then we say 8, it becomes 7. So there's more user action. So let's decrease this in size. So the next action that we did was we press a minus sign. So we press a minus sign, and then the result will still be 15. And then at the same time, and then we press 7, and we'll say 15 over here. So how are we going to change our math operators from plus to minus? So in order to do that, we have to make our math operator object to be different than the calculator number. So we're going to create another type which is called math operator, and inside our different calculator variable object, we are going to have this as a mixin. So mixin is just another way for you to differentiate stuff. So all of our 4 math operator, and let's say with math operator. Okay, so for our add, we refactor it. So basically, if action.last is not calculated add, then we will add this and we will have calculate the result of the parse calculator actions, and then we will notify listeners. So the next thing is that if it's a math operator, right? So if actions.last is a math operator, so what should we do if it's a math operator? So you can think of this is that this will only happen if the last action is a calculator add. If it's a calculator add, do nothing. Now if it's not, then actions.last is math operator. Then what are we going to do if it's a math operator? So it is not a calculator add, it might be a calculator deduct. So we're going to remove. So underscore actions dot remove last, and then else we will just show the result. And both of these actions will be added inside our calculator add. So if you were to put it as deduct, and then we will just change this to deduct. So let's save this. After we have created the deduct, let's put it inside our button, the minus button. So let's find our minus button. Okay, then let's put in calculator dot deduct. Okay, let's save this. Let's remove everything. Okay, and let's see the debug console. So let's put 7 plus 8 minus 8 plus 8 minus, oops, I want to plus. So let's plus 8. Let's see, 23, correct. So let's reset again. Let's clear this. 7 plus, I want to minus 8 minus 1. Alright, so the next thing is to make this into a common function, because the only thing that we're changing is the calculator variable. So what we can do is to just create this function. So if when, for example, action last is not equal to calculator add, do something. If not, do nothing. Then this action last is math operator, and then after that our calculator variable, the action, will be added. So the only thing that we are making dynamic or making the arguments of this take action function to be used for our divide, multiply, deduct, and add is our actions and the conditional statement. So now let's convert this add function to use the take action, and let's make it for all of this. So what we can do is we can just copy this calculator add. So take action, we have this, so we will have calculator add, that's our action, when action.last is not equal to calculator add. That looks very readable, and you can do the same with the different calculator action. So you can just change this, and there you go. So this is what it looks like. This is so readable. I love it, so proud of it. So you can do to the other 2 math operators, and there you go. And now let's convert all of the numbers to be functional, and also all of the math operator to be functional. So once we have done with that, we can now play around with the calculator simple functions. For example, 5 plus 6 times 3, that'll be 23. So 5 plus 6 times 3 equals 23. So you can play around with the numbers. 8 times 9, that's equal to 72. Then you can divide it by 9, that'll be 8. Alright, so all of these numbers are... So there's another bug where if we were to press 7 plus 8 equal to 15, and then we would type in 6, it should just show us 6. What we can do is to make use of this if conditional. So we will create another variable with another mixin. So we create another calculator result that extends the calculator variable. and then we put it in our show result function. So the show result, we just need to add this action dot add calculator result with the value inside it. So at the same time, inside our set value, if our last action is a calculator result, then we will reset our actions into calculator number 0 and our value into a 0. So if we can refactor this, so if you refactor this, if our last action is a calculator result, it will reset the action. And if our last action is not a calculator number, or the last action is a calculator result, the value is equal to 0. So if you were to have an equation, it will be 15. And if we were to put another new number and maybe add 4, it will become 10. So that's it. There are some things that I haven't finished yet, which is like the percentage or having the positive or negatives, and also the decimal place. So that might be another video, and that's about it. So I thought this challenge was easier than this whole tutorial, but it's totally not. So if you like it, give it a thumbs up, and if you want more of these kind of videos, click on that subscribe button and comment down below if you want me to do anything with coding. Alright, so hope you guys have a nice day, stay safe, and bye bye.